Hi, so as I mentioned in my previous video, the charger for my laptop has actually failed. I'm not getting any kind of output, so I figured I'd do a video here and we'd test it just to see what might be going wrong with it. So I'm going to plug it in. Got a green light. That means it works, right? It's got to be working. There's a green light. Okay, put the meter here. Not sure if you can see that with the glare. Oh, that's better. Okay. Let's test the output here. Let's see what we get. Well, that makes sense. Nothing. But the green light's on. Okay, so first I have to try and hold that. I noticed that this here looks a little dodgy, but twisting that around doesn't seem to affect the voltage at all. But I also noticed that here, this also looks pretty dodgy. Hold on. Look at that. That was it. I hold that a certain way, let go. I don't know if it's broken wire, if I'm actually just shorting it out. But power supply like this would have some short circuit protection built in. So there's the problem. It's right here. But unfortunately, because of the strain relief right here, I don't think I'm going to have much luck unless I actually open this up and actually chop this wire here and then bring it back further in. So I'll have a slightly shorter cable, but that doesn't bother me much. That shouldn't be an issue. So I'm going to get this thing apart and we'll go from there. I cannot tell if this is actually ultrasonically welded or glued. I don't think it's a snap fit. I think if I were to take a screwdriver to that, it would actually just dent the plastic in. So some of these are actually glued, and what I think I might try to do first, a lot of people use gasoline. They'll soak the edges in gasoline. I really don't want to bring gasoline in here into the lab and fume up the place. I do have some other chemicals I could try. I have brake cleaner. That is kind of nasty as well, but let me try brake cleaner and see what that does. Okay, so I've never tried this before to actually release the adhesive. Ooh. Oh, and it stinks. I get some more paper towel. I really hope this doesn't have a corrosive effect on my ESD mat, because I've gotten it everywhere now. I really don't care if it eats away at this plastic or not, but I just don't want my ESD mat getting messed up. Ooh, these fumes. It's not smell-o-vision, but it's pretty harsh. There. One more side. Oh, hit the camera. Okay. So, I think that's hopefully all I have to do here. Let's see. Oh, it's like magic. It's like magic. No work whatsoever. It just came right apart. No prying. Nothing. I don't know if this was actually cracked or if somebody had gone in here before and that got broken out with the screwdriver, or if that's the actual adhesive. I'm not sure what's going on there. I can't tell. Maybe. I don't know though. It doesn't look like this thing had ever been opened. Unless it was super glued shut. I don't know, that's weird how it did that. But no, I don't believe this has ever been opened. But yeah, so this is just CRC brake cleaner. Probably any brake cleaner will work. Probably anything with like hexane, octane, anything like that will work. This is tetrachloroethylene. So anything like that, yeah, I guess that'll do the trick. So we're in. Easy. So this should just come out. We've got our two ends. Zoom out here. Looks like that's our two wires there. So this strain relief needs to actually move back. Let me grab that with some pliers. And see if I can pull that strain relief back. Ooh, it's not looking good. It's not looking good, but I know that there's a problem here, unless it's a cracked solder joint or something like that, but no, it sure doesn't look like it. No, I think the issue is here. I think that's the issue right there. Hold on, let me take a look at this and we'll figure out what to do. So what I ended up doing is I just chopped the end off, and that left these two here. The strain relief was over that, but I pulled that off, and you can see where that actually failed. It's right there. It went open, it actually broke. So it's broken wire. Right there, sorry. So what I need to do is chop these out, splice this, or split it rather, and solder that in, get it through the strain relief here, which I suspect is probably not going to be very easy, and put it back together. So in order to get this in there, what I ended up having to do was to drill it out, the strain relief, and then I just pushed a screwdriver through it to clear out all of the debris, and then I used a little bit of wire pulling lubricant that I had from other projects to actually get it through there. I don't think I could have gotten it through there without that. Perhaps you could use something else like vegetable oil, any other kind of lubricant that you might have available. I'll just leave it at that, and that should be enough to get it on there. So now what I'm going to do is cut this back, and we'll solder the new wires into the actual PCB. Okay, so I've just put a little bit of heat shrink over the shield side here, just so that all that bare metal under it doesn't short anything out inside the case. And just going to use my SMD soldering gun to soldering tool to shrink that on there. Really handy for heat shrink, having one of these. So yeah, just got to get that soldered into the PCB now. So this ground connection was kind of corroded. The wire was corroded. You know, it's oxidized, as you would expect it to be. So I was having trouble getting solder to adhere. I actually ended up using this water-soluble flux. It is something that came with one of the pipe soldering kits for soldering copper pipe, but it worked great in this situation. So no problem. Now it's on there nice and tight. That's not going anywhere. Okay, so the only thing left to do is to get it back together and to test it. So we have this there, like so. Strain release is in there. So we're just going to put it together temporarily for now, just to be able to test this out and make sure everything works correctly before we glue it into place. There we go. Just like new. Okay. So I'll plug it in. Hopefully there's no sparks. We have a green light. Now the trick is, let's get the laptop out here. Get out of there. Okay, so we have a charge light down in here. Let's plug it in and see if that comes on for us or if we blow up the computer. Actually, no, I'm pretty confident in the work that I did. I was going to check polarity, but I feel good. Aha! There it is. We have our charging light. It's working. That's all it was. It's just a broken wire. You know, that tends to happen on 11-year-old laptops. But yeah, at this point I'm just going to glue it back together with some super glue. Nothing too exciting there, won't bother with that. Anyway, I hope you found this interesting, especially the trick with getting this apart. I think any kind of organic compound like gasoline, kerosene, the brake cleaner, of course, maybe carburetor cleaner. I'm sure there's a lot of other things that you could think of that might do that. Anything that can seep in there and is some kind of organic compound, octane, hexane, that sort of thing. Butane might actually do it, but butane has a tendency to evaporate. So let me know in the comments if you guys have any other tips or tricks of other types of chemicals that work pretty well for that. But I hope this helps somebody out there who has trouble repairing their laptop charger. You don't have to throw this thing away and buy a new one. That was absolutely free. So, you know, try to fix it yourself. It's definitely worth doing. Alright, I hope you enjoyed that. Oh, one more thing. By the way, I was wondering if acetone might be one of the things that could actually dissolve the glue on something like this, one of these chargers. If it's like super glue where acetone will actually dissolve it. Not sure. That would be worth trying. It'd certainly be less harsh than using something like brake cleaner or gasoline. I would not recommend using gasoline. Anyway, I wanted to do a little shout out for a product that I have here. Anyone that has a Rigol DL3000 series of electronic loads knows how annoying and burdensome these terminals are. They're basically just screw terminals like that, but there's no wire hole in here or anything. It's just basically for a lug. And it's not easy to smash a wire in between these two since there's no hole. It doesn't want to stay there. And a lot of times you just want to use regular test leads. You don't need the full 40 or 60 amp capability. So I have designed and will be selling on eBay and probably other places this little adapter here. Just a PCB with, these are Pomona high quality banana jacks on it. It's got a wire hole through it and a place that you can plug into here, and these are actually good for 15 amps. So it's not good for the full 40 amp of this load, but how often do you really need that big of a load anyhow? These are good for 15, and that's probably plenty for most scenarios. So it just screws in there. Just like that. Now you have your normal banana jacks that you would use. Anyway, if you want one, I am going to have them on my eBay store. That's my name on eBay is TOWLERAR. And I also have my old, it's actually down here, my old cap tester. I'll be selling that one on eBay as well. It's actually already listed. I believe it's at $265 current bid. And these are hot commodities, so feel free to go on over there and make a bid. I've taken good care of it. It's well calibrated. It's I definitely recommend that kind of cap tester. Anyway, just had to give that little product plug.